The fundamental idea of Anaconda is that one can have one's cake and eat it too. Defense bastions consider UAS development, we believe, in too linear of a manner, and defense challengers consider UAS development in a manner that they think is really very innovative, but that complies with a challenger standard design. They're all set in the same sort of ways. They consider themselves innovative, but it's really the same product at heart, just improving it. That's not a bad thing, but it's not necessarily innovation in the way that one wants to see it. For these large defense bastions, which are, I'll admit, designing really incredible, sort of exquisite systems, they generally fall into the following categories. Either central propeller glide UAS, something similar to a miniaturized Spitfire, tilt rotor VTOL UAS, think of a little Osprey, and then dual offset propeller glide UAS. Think sort of Mosquito, miniaturized remote control Mosquito. That's what the larger firms are focusing on, whereas challenger firms really fall into the following categories. They're either going for a simplified quad rotor UAS, Anvil perhaps, or they are going for a rear central propeller glide UAS, and that is often in the form of an expendable munition, a loitering munition in the majority of cases. And still, even in that regard, they only really fall into two categories, with the only big ideas being thrown about are, coordination and loitering, basically all falling under the bracket of increasing autonomy. We didn't want to do that. We wanted to create something that was more versatile and, in regard to innovation, that actually had broader scope. Anaconda UAS is quite different. It utilizes automated, internally collapsible, rotational dodeca rotor design. That's 12 rotors in quad formation along the length of the unit that can basically fold up inside. Unlike nearly all other firms, our tactical UAS isn't small and chunky, but rather long. It's 1.5 meters long, 1 meter and 55 centimeters. Anaconda UAS differs from the competition at the most fundamental level. Now, EMC Operations is thinking ahead, not only to the next generation of UAS, but to the generation that comes really twice after that. The current generation of UAS, we really think, is either fixed wing, class 2 to 5, focusing on tactical ISR only, with larger drones being able to strike. Now, these larger drones are obviously bulky, the smaller drones are not very aerodynamic, and all of them require frequent refuel, and are somewhat unreliable and rather expensive. And obviously, they tend to require actual fuel in that regard, which is not necessarily such a great thing when you're dealing with something that needs to be quickly turned around. Now, the new generation of UAS by challenger firms are generally electric and fall into two categories, either small unit ISR or target engagement via loitering and, ultimately, self-destruction. Kamikaze drones, for lack of a better word. Now, units are less expensive, generally, and more reliable, but there is a higher chance that they are irretrievable once deployed. That's not a good thing. Now, the generation we predict coming after this is the micro-sizing of the prior generation. Loitering self-destruction munitions being made smaller, having some sort of ISR and sort of centralized battle space management system awareness in order to develop high technological quality and something that is more mass producible, but it will still be reasonably expensive. And it will still, at the end of the day, blow up and likely be irretrievable. Now, we have skipped to the generation after this that doesn't even exist yet. Concepts that haven't even really been brought up when talking about UAS, concepts that people haven't tried out yet. And we think that they work, despite the fact that they're not being followed by the rest of the industry. The point is, like me, a lot of UAS are monotonous, and it's all the same sort of thing. We've gone for a radically different design. Not to disrupt, but because we can.